Let's take a look at this normal distribution problem about high blood pressure. So we have a mean of 121. That'll be important to know. And the standard deviation of 23. Now the high blood pressure stage 2 is 160. So I want to look up this, I want to compute the z-score for 160. And the z-score is x minus mu divided by sigma. So we have 160 divided by mu, which is 121, divided by sigma, which is 23. So let's work this out with a calculator. 160 divided by 121. Make sure to, it's divided by minus. Make sure to work the numerator out before you divide by the denominator, unless you want to use parentheses around the numerator. So our z-score table that I have in the background is only 2 digits, so we have to round here. 1.70, rounded to 2 decimal places. Okay. While we're doing z-scores, let's see, this is greater than 160, we can do that. Sample 2,000 people, between 140 and 160. In order for this, we also need to work out the z-score of 140. So that's going to be 140 minus the mean, 121 over 23. So again, the other way you could do the z-score in your calculator is parenthesis the numerator before the divide the denominator. That way you could just type it in 1 instead of doing it in 2 steps. 0.83. Okay, I believe there's more. Yeah, there's a part D 30th percentile. We'll have to look into that. But we are ready now to answer the first question. Around what percentage of the adults have stage 2 or higher? So in terms of a bell curve, we have positive 1.7 or higher. This is the stuff on the right. Now our z-scores, though, have stuff to the left. So we can work this out in 2 ways. Because of the symmetry, this little area on the right we're looking for, we could also look for an equivalent area on the left, and we'd find that with the negative z-score table with negative 1.7. So let me look into that real quick. Negative 1.7, negative 1.0, 1, 2, 3, 4, 5, 6, 7. There it is. Negative 1.7. Oh, I've got negative 1.07, sorry. Negative 1.7, here it is. 0.0446. That rounded to 2 decimal places would be 0.04. So from the z-score table we get 0.0446, which would go to 4.46%, which we'd then round to 4.5%. This is using the negative z-score table, and that's because the area on the left, this shaded region, is similar, is actually the same area on the right of the positive z-score. We could also look up the positive z-score, 1.7, and here we have 0.99554. This would be the area to the left. So we could also work this out with 1 minus the positive z-score number, 0.9554. And that would be, calculate it, make sure we get this right, 1 minus 0.9554, same exact number. We would then round to the appropriate 4.5%. Excellent. Next up, if you sample 2,000 people, how many would be in the stage 2? Well, we have the percentage, 4.5%, so I'm guessing they're going to stick with the 4.5% versus the actual number we have, which is still an approximation of the z-score table. Sorry, the z-score table is an approximation of the true value. So we're approximating approximations, never a good idea, but I bet that's what they have for their final answer, 90 people. Okay. Now, between 140 and 160, what we have to do is we have to look up the larger value, 160, which will be, oops, why was it not drawing? There we go. There's the 161. And if we subtract the 141, we will get that area in between. So the 160 we've already looked up, and it was the 0.9554. We subtract the area that corresponds with the z-score of the 140, 0.83, 0.83, 0.7967. And we get 15.87%, which would be 15.87. Now notice the answers fit 15.94. What we're seeing here, unless I made a mistake, and I don't think I did, 0.83, double check. Yeah, no, we have this right. This z-score table, since it only allows 2 digits for the z-score, we've already rounded to get the z-scores. If we were to use a calculator like the one I have shown here, using the normal CDF, we can actually tell it that we want the area under the curve between 140, and 160, where the mean is 121, and the standard deviation is 23, and it'll compute the area exactly. That's how they're getting this 0.94 decimal part of the answer, is they're using a tool that gives the exact area underneath, whereas we, and mostly what you get on finals or these z-score tables, are using an approximation tool. Know that on a final you will, or at least you should, receive full credit for the approximate answer using the tool that is given. Okay, so with that being said, if the answer is a little bit off, I'll pull up the calculator and show you that it is the correct answer they're giving, even though we're generating this other answer. All right, last thing, doctor tells you you're in the 30th percentile for blood pressure. What is your blood pressure? All right, 30th percentile, inside these tables are decimals, like this is 50th percentile, 53rd percentile, 57th percentile. We want to look for 30th percentile. Oh, right here, very close. This one is 81, 15. 15 is closer to 0 than 81, or 15 is closer, yeah, down than this roundup. The closest one I can get is 0.3015. Z-score is negative 0.52, negative 0.52. So we look up the percentile in the middle of the table, and then we can find the z-score that goes with that. Now from our z equals x minus mu over sigma, we can solve for x, multiplying by sigma, adding mu, x equals mu plus z sigma. So in this problem, the real score would be the mu, 121, plus the z-score, negative 0.52, times sigma, 23. And our calculator says 121 plus 23 times negative 0.52, 109.04, the exact value that's in their answer. There's an inv norm. I think I know how to do this. 30, let's not worry about it. There's a way for the calculator to do the exact answer as well. But we got the exact answer, so that's great. Hope this helps.